This chapter discusses about number system. So the first topic in this chapter is about real number. The following are the learning outcomes of this lecture of this topic. So we start with natural numbers. So basically natural numbers is the set of counting numbers denoted by capital N. So we have a 1, 2, 3 and so on as the members for the set. So we have another set which is prime numbers. So prime numbers is the number that is greater than 1, and other than 1 it can only divided by itself. So we have set of prime numbers. We have 2, 3, 5, 7, 11 and so on. Alright, now we move to the second set, which is the whole numbers. So basically whole numbers is the natural numbers together with additional element, which is 0. So we have 0 as the additional element. So whole numbers is denoted by capital W. Alright, next is integers. So integers basically is the whole numbers. Okay, so whole numbers together with the negative of counting numbers. Negative of counting numbers. Okay, alright, so this triple dot indicates that we move from negative infinity, and this triple dot means that we move towards positive infinity. Okay, the set of integers, the combination of whole numbers and the negative of counting numbers. So basically integers can be further divided into several classes. We have a positive integers, negative integers and 0. For the positive integer, don't forget to put this plus sign. Okay, for the set of negative integers, don't forget to put this minus sign. And then we have 0 at the middle. That means if we consider 0 is neither positive nor negative integers. But when we discuss about non-negative integers, so it is including 0, because 0 is a non-negative number together with the positive numbers. Alright, next, integers also can be divided to another classes, what we call as odd numbers and even numbers. For odd numbers, all odd numbers can be formulated as 2k plus 1, where k can be any integer. If we replace k with, for example, 3, so we have equal to 7. So 7 is an odd number. And for the even number is formulated as 2k, where you can replace k with any integer. For example, 2 times 11. Okay, so the outcome is an even number. Alright, now we move to the next set, what we call as rational numbers. So any number that can be represented as a ratio or quotient of two integers. Okay, for example, we have a over b, where a and b are integers with additional condition b does not equal to 0. Why? Because if b equal to 0, then this fraction becomes undefined. So any number in this form can be categorized as rational numbers. Okay, so for decimal numbers, okay, decimal numbers also can be irrational numbers. Okay, with condition, these decimal numbers must be terminating decimal numbers or repeating decimal numbers. For example, we have 3.175. So there is no other number other than 5 after 5. So this is what we call as terminating decimal number. So this kind of number also categorized as rational numbers. Another form of a decimal number is, for example, 0.17, 17, 17, and so on. So for this kind of number, we have a repeated pattern. So this kind of number is what we call as a repeating decimal number. Okay, we have pattern here, repeated pattern. So this kind of number also considered as rational numbers. So basically all natural numbers, whole numbers, and also integers are rational numbers, because these numbers can be represented in quotient form, a over b, where the denominator or divisor is fixed equal to 1. So any integer numbers, any whole numbers, in any natural numbers basically are rational numbers. For example, we have negative 15. Negative 15 actually can be written as negative 15 over 1. So this is a fraction form, so it is a rational number. Alright, so other than rational numbers, we have irrational numbers. So what is irrational number? Any number that cannot be written as a quotient and non-repeating decimal number. So it is denoted by, if the rational number is denoted by capital Q, so for the irrational number it is denoted as Q bar. Okay, so we have this example. This is a non-repeating and non-terminating decimal number, so it is a irrational number. So same goes with the third 3 and also pi. These two numbers also categorized as irrational numbers because in decimal form these two numbers are non-repeating and non-terminating decimal numbers. Alright, so we have example for the rational numbers and irrational numbers. As you can see here, all these decimal numbers can be represented in fraction form. So that is why these numbers are categorized as rational numbers. Where on the other side, we have these numbers which are decimal numbers without any pattern or without any repeating pattern. Also, decimal number that is not terminating number. So these numbers are categorized as irrational numbers. Okay, so the combination of rational and irrational number form another set, another larger set, what we call as real number. So this is the pictorial representation of the relationship of the set of numbers. We have the smallest set is natural numbers, followed by whole numbers, and followed by integer, and then we have a set of rational numbers. Alright, so another set other than rational numbers, we have a separated set, what we call as irrational numbers. So the combination between rational and irrational numbers form the set of real numbers. So from the diagram we can see that natural number is a subset of whole numbers is a subset of integer subset of rational number, and rational number subset of real numbers. So the combination or the union of these two sets, rational and irrational number, form real number set. Alright, so we consider the following example. We are given one set, so our task is to identify the following set. The first set is natural number, so based on the given set, so obviously we have 3 and 8 as the natural numbers, and for the whole numbers we have additional entry which is 0. We have 0, 3 and 8. For the prime number, the only number that can be divided by 1 and itself in the given set is 3. Okay, how about 8? 8 can be divided by 1, 2, 4 and 8. So that means 8 is not a prime number. So we only have 3 as the prime number. Next is negative integer. So don't forget to put this sign, negative sign. So we have negative 5, negative 3 and negative 1. Okay, how about if I ask you to list down all the non-negative integer? For example, non-negative integer. So the answer are, okay, the answer is containing what? 0, 3 and 8. Okay, because 0 also is a non-negative integer. Next is even number. So in this even number we have 0 and 8. Okay, so why 0? Because even numbers can be formulated as 2k, where k can be any integer. So 0 is an integer, right? So you can replace k equal to 0. So the outcome is 2 times 0 equal to 0. So 0 is an even number. Next is odd number. So we have negative 5, negative 3, negative 1 and also positive 3. Alright. So now we move to the next example. Express each of these decimal numbers, okay, as a quotient. So we have two decimal numbers, and our task is to convert these decimal numbers becomes a quotient number. Okay, first of all, as we can see here, we have triple dot. So that means these numbers we have non-terminating numbers. But then as we can see here, these numbers has repeating element. Okay, repeating element 5959. Okay, so that means these numbers are rational numbers, and we can convert these numbers become fraction or quotient form number. Alright, so we start the first example. Let the given decimal value as x. And then we denote this equation as equation number 1. And then the second step is to multiply the equation number 1 by 10. That means we multiply both sides, left and right, by 10. So we have 10x. And at the other side, we have 15.555 dot dot dot. Okay, don't forget to put this dot dot dot. Alright. Now, if we subtract these two equations, so the outcome is after the decimal point, we have 0. After the decimal point, we have 0. So that means we can subtract equation 2 minus equation 1. So we have 10x minus x is equal to 9x. And this value minus this value, we have 14.000 dot dot dot. Because we have 0 after the decimal point, so we can omit this part. So we have remaining 9x equal to 14. So this time we have integer, so we can proceed to bring 9 to the other side. So we have x equal to 14 over 9. Alright, for the next example, almost same steps, okay? So we're given this number, but we're aware that the repeated pattern start from here. Okay, 59, 59, triple dot dot dot. Alright, so the first step is to multiply the first equation by 10. Okay, so we multiply both sides of equation 1 by 10. So we have 10x equal to this number. So this number is 54.5959. Alright, so now the next step is to multiply equation number 2, this equation, by 100. So we have, okay, 10 times 100 equal to 1000x. And for the other side, we have this number. So why we do we need to further multiply with 100? Because we want to make sure that if we subtract these two equations, so we have this value. Okay, we want to make sure that after the decimal point, so we have 0 value. So we can omit this part after we subtract the equations 3 and 2. 3 minus 2, so we have 0 after the decimal point. So that means we have integer value here, so we can take this value, the 990, to the other side. So I have this fraction. So don't forget to simplify this fraction to give the final answer. Alright, now we have several properties of real numbers, okay, related to additional and multiplication operations. We start with closure property. Closure property means if we add two real numbers, the outcome also still belongs to the set of real numbers. So same goes with multiplication. We multiply two real numbers, the outcome also still in the set of real number. So for commutative property is related to the position of the numbers. So we change the position of the numbers. For example, a plus b, so the value is equal to b plus a. So same goes with the multiplication. AB is equal to b times a. We change the location for the numbers, but the outcome still same. So associative property means we have a parenthesis. So parenthesis in mathematics means we need to give priority to the value inside the parenthesis. So for example, in this equation, if we solve the value in this parenthesis and we add with c, the answer is always equal to, we solve the value in this parenthesis and we add with a. We got the same value because it is equal. So same goes with multiplication. If you multiply first a and b and we multiply with c, the answer is always equal to, we multiply first b and c and then we multiply with a. The answer also same. Okay, for distributive property, again we are dealing with parentheses, but this time we combine the addition and multiplication operation. So we distribute a inside the parentheses. Okay, so we have ab plus AC. Alright, next is for the identity property. So a plus 0 equal to 0 plus a equal to a. So we add a with one value, we get the original value. That means 0 is the identity element for the addition operation. Okay, for the multiplication operation, we multiply any real number with 1, we got the original number. That means 1 is the identity for the multiplication. Next is inverse. Okay, for the inverse, we have a real number a, we add with the negative of that number, so we obtain the identity element of addition 0. That means the inverse of a is negative a. So for multiplication, we multiply a with 1 over a, we obtain the identity element for multiplication, which is 1. So that means 1 over a is the inverse of the real number a. All right. Now we consider the following example. Write down the type of properties for this statement. We first start with A. We have 3 plus 3 plus 4x equal to 4x plus 3. So obviously we just change the location, the position for these two numbers, and then the equation remain true. So this is a commutative property. The next one is we have a combination of two operations, okay, addition and multiplication, which is comes from the parenthesis. So that means it is a distributive property, combination of addition and multiplication operations. Next, we have 3ab plus 0. We obtain the same value. So that means this is the identity for addition operation. For identity for multiplication operation is 1. So identity for addition operation is 0. So this is the identity for addition operation. Next, we have 2 multiply with 3n equal to 2 times 3 outside the parenthesis n. Okay, that means we play around with the parenthesis and the equation remains true. That means this property is associative for multiply or multiplication operation. Okay, now the example, given two real numbers a and b, and it is given that ab equal to 1. So our task is to prove that a is equal to 1 over b. Okay, so this is the simple example of mathematical proof. Okay, how to do it? So we can use all the given properties for real numbers to solve this problem. Okay, we're given that ab equal to 1. AB equal to 1. So our aim is to get 1 over b at the right hand side. So what we can do, first of all, we multiply both sides by 1 over b. Okay, both sides. We cannot multiply on a single side because the equation becomes not equal anymore. So we need to do the same operation at both sides. So we multiply 1 over b to the left side and right hand side. So we have based on associative and identity property. So we have this equation. Okay, so 1 multiply with this one, so we have the identity for multiplication is 1, right? So that is why we have identity property here. So this one, if you multiply b with 1 over b, the outcome is the identity element for multiplication, which is 1. So that means we have the inverse property. Because we have parentheses, we have associative property. So you need to identify every property in each steps. And finally, we come out with the answer. 1 times a is equal to a because 1 is the identity and the other side we have 1 over b. So that completes the proof. Okay, now we move to the number line. The set of numbers that corresponds to all points on the number lines is called the set of real numbers. So along the lines we have real number values. Okay, the real numbers on the number line are ordered in increasing magnitude from the left to the right. Okay, from negative infinity we move towards the positive infinity. Okay, all right, so along this real number line we have real number values. Okay, we have for example, we have natural numbers 1 2 3, we have whole numbers 0 1 2 3, we have integers, move from negative to positive integers. Okay, what else? We also have rational numbers. Okay, we also have irrational numbers. So all real numbers can be represented using this real number, using the number line. Okay, now we learn about the type of intervals. Okay, because we are dealing with a number line, so we have types of intervals. The first type of interval is what we call as open interval. The open interval is denoted by this kind of parenthesis. Okay, this kind of parenthesis. So what does it mean? That means x, the member for this set. Okay, this is set. Okay, the member for the set is any number which is represented by x, and this number is located between a and b, between any number along this line. Okay, any real number along this line, but excluding a and B, because this is an open set, because x is greater than a, that means doesn't include a, and x also less than b, that means doesn't include b. So that means open interval excluding a and b, but between a and b, any real number along this line, but then excluding a and b. Next is closed interval, so we have this square parenthesis a, b. Okay, so that means it is set of real numbers denoted by x, where x is located between a and b and including a and b, because x could be greater than or equal to a and x is less than or equal to b. That means including a and b, any real numbers, okay, in this line including a and b. Okay, so other than open and closed intervals, we also have half open and half closed intervals. For the half open and half closed interval, we have two types. The first one is we have this set x, where x is greater than a, that means the open interval is here, okay, at the left side, and it is less than or equal to b, so that means at the right side we have a closed interval. Okay, for the next set, okay, we have half closed and half open interval as well, but this time we have the closed interval at the left side and we have open interval at the right side. Okay, if you can see here at the graph, we use the white circle representing the open interval, okay, white circle, and we use black circle to represent the closed interval. Okay, so how about this one, for the half open and half closed interval? So white circle, it is an open interval, black circle, it is a closed interval. All right, now example, list the number described. Okay, list the number described and graph the numbers on the number line. So that is the question. We start the question number 1. Okay, the whole number less than 4. First of all, before you proceed with the number line, first of all, if you can list down the entries or the elements for the set, list down the entries first before you proceed with the number line. Okay, so we list down the member for this number. So we have whole numbers less than 4. So whole number, we start from 0. So we have 0, 1, 2, and 3. Okay, because it is less, these numbers are less than 4. All right, so how to represent on the real number line? Because we have distinct entry, we have 0, 1, 2, 3, and 4, so we don't have line, we only have the black dots here. Okay, to represent these entries, we have 0, 1, 2, and 3. Okay, if you put line here, what does it mean? Okay, let's say you put line here. Okay, it is wrong. Why? Because this line representing any number along this area. So it can be 0.5, it can be 1.5, it can be 2.135, and so on. So that is why you put the black dot. That means representing the distinct elements instead of using the line. All right. Next example, the integer between 3 and 9. So the key point here is between. That means when between, that means excluding 3 and 9. So we can list down all the entries. We have 4, 5, 6, 7, and 8. Okay, excluding 3 and 9. Okay, so we using the number line. So we have a 4, 5, 6, 7, and 8, because the numbers are distinct numbers, so we just simply use the dot instead of line. Okay, so remember, when the question asks you to list down the integer between, that means excluding the given number. In this particular example, excluding 3 and 9. Okay, next example, list the number, describe and graph the number on the number line. Again, the same question. The first one is the integer between 3 and 9. Okay, I think this is repeated example. We move to the next one. The integer greater than -3. Okay, for this kind of set, so we have all integers greater than. That means not equal to, greater than -3. So we have -2, -1, 0. And don't forget to put this triple dot, because we have more and more entries, and all these entries also distinct entry. Okay, so we have -2, -1, 0, 1, and again don't forget to put this triple dot sign. That means we have more and more entry. All right, in this example, represent the following interval on the real number line and state the type of interval. Okay, state the type of interval. First of all, we have this closed interval. So in this type of interval, so we have this solid line, move from -1 up to 4, and we use black circle because we're dealing with closed interval. So the answer is closed interval. So for this one, okay, this one, the set contains x, where x located between 2 and 5, but excluding 2 and 5. So that means we have open interval. So we have solid line here, black line. At the end of this line, we have white circle representing the open interval. So the next one is half open and half closed interval. So we have at the left side we have closed interval, at the right side we have open interval. So we have this kind of line. We have black dot at the left side, and we have arrow here. Okay, at the right side we have arrow because we are moving to positive infinity. So don't forget to put this arrow direction. Okay, from 2 up to positive infinity. This is half open interval. Next is we move from we have a set x contains x is less than or equal to 0. Okay, so this is 0. Okay, because this is less than or equal to, that means we're dealing with closed interval. So it moves to negative infinity. Again, don't forget to put the solid line together with the arrow of the direction of the arrow moves towards the negative infinity. So again, this is a half open interval. Okay, now the intersection and union operations. Given two intervals, we have given two intervals a and b. Okay, interval a, so now we represent the interval a on the number line. Okay, it is between 1 and 6 but including 1. So that means we need to put black circle at this side, and it is excluding 6. So that means we need to use white circle at the other side. Okay, so we move to the second interval. We have a b, so this one is for interval a. Now we move to the interval b. So interval b is an open interval, move from -2 up to 4. So we are using white circles to indicate that it is an open interval. So now the combination of these two intervals for intersection, that means the area covered by both lines. So we have this area. Okay, we have this area covered by both lines. So we have, okay, we have black circle here, so we need to use black circle at this side. We have white circle at this area, at this side, so we need to use white circle at this area. So that means this is the intersection between the two intervals a and b, the area covered by both intervals. Another one is union. The union of these two intervals is all area covered by both or any one of these two intervals. For example, in this area only covered by b, so we include also this area. This area only covered by a, we also include this area, and this area covered by both intervals, so we also cover this area. So the combination of these three areas form the union of a and b. Because at this side we have white circle, so we have this kind of circle. Because at the right side we have this circle, so we have this kind of circle for the union operation. Okay, so finish with this example. Next, solve the following using the number line. Okay, we are given two intervals and we are also given the union operation. So we start with the first interval. close 0 up to open 5. So close 0 up to open 5. Okay, we have this line. The second interval, open 4 up to open 7. So open 4 up to open 7. So we have this line. Now the question asks you for the union operation. So union operation means the all areas covered by both or one of these two intervals. So because this area covered by the first interval, so we include this area. So because this area covered by the second interval, so we cover this area. So this is the combination of these two areas. We also include this area. So we have the whole number from 0 up to 7. Because of the left side we have closed interval or black circle, so we use this solid circle. Because we have at the right side we have white circle, so we use this kind of circle for the union operation. So after all, don't forget to conclude your answer. Give this as your final answer. So the final answer is from close 0 up to open 7 as the final answer. Alright, so this is another example. So if we move from negative infinity up to 5, so don't forget to use this kind of line. We have arrow, okay, pointing towards the negative infinity. Okay, we have 5 here, so because open, we have white circle. For the second interval, we have open -1, open 9. So use this white circle. We use this white circle. So because the question asks you for the union, for the intersection, so we only find the area covered by both lines. So we have this area covered by both lines. So at the left side we have a white circle, so using white circle. At the right side also we have a white circle, so we're using white circle. So don't forget to finalize your answer. The answer is open -1 up to open 5. Next is, okay, from negative infinity to close 0. So we have this line. From close 0 up to positive infinity, we have this line. Okay, because we're dealing with negative and positive infinity. So don't forget to put this, the direction of the arrow. So because the question asks you for the union, so the combination, the whole area covered by both lines. Okay, this area. Okay, because at the left side we have arrow, so we put arrow. Because at the right side we have arrow, so we also put arrow. So don't forget to put your final answer. So the final answer is from negative infinity to infinity, which also can be simplified as real set of real numbers. Okay, now it becomes more complicated. We are given 3 intervals. Okay, so first we consider one by one. Okay, because we are given 3 intervals. First of all, we consider the first 2 intervals. Okay, we consider the interval open -4 up to open 2, so this line, and then open 0 up to close 4, this line, and then we combine together because we are using union operation. So all area covered by both lines, and then at the left side we have open interval, at the right side we have closed interval. So this is the outcome for this operation. And next is to consider the third interval. So the third interval is from close -2 up to open 2, and then the operation is intersection. That means the area covered by both lines. Okay, covered by both lines, so we have this area, okay, covered by this interval and also covered by this interval. So at the left side we have solid circle, which indicates a closed interval. At the right side we have this white circle, which indicates an open interval. So the answer is, okay, so don't forget to provide the final answer. The final answer is close -2 up to open 2 as the final answer for this question. Okay, next example. We are given one set A and set B, and our task is to show that the intersection between these two sets results this interval. Okay, we start with the first set. So A is, we have a open -2, open -2, and close 5. Close 5, so this is the A. And then for the set B, we have a open 0, and close 7. Okay, so we have this line. And then the question asks for the intersection. That means the area must be covered by both lines. Okay, at the same time covered by both lines. So we only have this area. Okay, covered by this line, covered also by the second line. So this area. So we need to look at the left side. We have this. Okay, this kind of circle. So we have white circle. At the right side we have a black circle. So we have black circle. So that means our final answer is open 0 up to close 5. Don't forget to provide the final answer. Okay.